Hi, good morning, everybody. Welcome to this, sort of overcast, but not snowy, not super cold winter morning, where I'll warm things up with some organic chemistry. Oh, that was good. Anyways, it worked. Quick update. I tried uploading some files and it didn't work to my U drive. People I contacted said you should contact the help desk, which I did this morning. Someone got back to me very quickly, which I appreciate. And this afternoon, I'll call that person. We'll try and get this worked out. If not, it'll be on YouTube soon. So anyways, give you a status update. All right. It's new functional group time. Dr. White is very happy. Functional groups, new ones, are always fun. And this new functional group, there are two of them we'll talk together. The first one is called an aldehyde. And an aldehyde is carbon double bond to oxygen that has a hydrogen and carbons attached to the carbon double bond to oxygen. You can draw it this way. Here I show the bond angles of a carbon and a double bond, 120 degrees. More likely on my test than other places, like on the board, I'll write it this way. And this is an aldehyde. Now, there are other ways of writing aldehyde, which I will do. One is, with the line method, you don't show carbons. Every bend in the line is a carbon. This is another way, and once in a while, I'll draw it that way. Because when I'm talking to other PhD chemists or organic chemists, I'm going to write it this way, because we're lazy. But I'm going to try mostly to stick to this way. Now, one other way, which sugar chemists write it, this hydrogen, just like you have CH2, you put the hydrogen to right up a carbon, you can write it this way. Now, I think this is cooler and cooler than this, so most likely I'm going to do this. When we get to sugars, my software likes to do it the last way. And if you look on the internet or in the other books, you'll see aldehydes that are in sugars, which we'll get to, written like that. So this is an aldehyde. Now, a similar but different functional group is called the ketone. And even though it's pronounced ketone, there's no Y in the name, but it is a ketone. And here, you have the same thing as in an aldehyde, carbon double bond to oxygen, but now you have two R groups, which can be the same or different, which is why I have R and R prime. Remember, R is just like X and Y in math. It can be anything. In math, it's numbers. In organic chemistry, it's something with carbon and hydrogens. And even in real life, it can be other things too in the R group. But for this class, let's keep the carbon and hydrogen. And this is the ketone. Now, similar to an aldehyde, I can draw it this way, where this carbon is denoted by a bend in the line or intersection. Aldehyde, carbon double bond to oxygen, R group hydrogen. Ketone, carbon double bond to oxygen, R group, R prime, two different R groups. Now, I have something I should admit, and that is, over the next couple lectures, if it looks like I'm having way too much fun, I am. Because Dr. White, and Mother Nature too, but really Dr. White loves ketones and aldehydes. They've been nice to me. I've been nice to them. In fact, how many of you are familiar with the term comfort food? You know, if you're not feeling good, I'll eat this and I'll feel better. I have some comfort foods, like most dangerous is Lay's potato chips, but I was trying to stay away from that. But now you're going to find out, ooh, he really is an organic chemist. And that is, aldehydes and ketones are my comfort functional groups. If I'm having a blue day, I can sit down and think about those and I automatically feel better. There's another functional group I'll talk about that's a comfort functional group for me too. Why? Because my first and last patents, I used ketones and aldehydes. My PhD thesis dealt with specialized ketones. I'm an expert in ketones and aldehydes, and I like them. So I'm going to have a lot of fun. Hopefully you will too. So you have ketones and aldehydes, and you'll find, I already know, that certain reactions, ketones and aldehydes, react the same. And when talking about it, I'll write it in a general way this way. And this means when R prime is hydrogen, it's an aldehyde. When R prime is carbons, it's a ketone. That's a general way of doing it. I could also do it this way. More likely, this is how I'm going to do this on the board. And when I do it, I'll talk about it and let you know about that. Now, if you look at ketones and aldehydes, they both have something very special in common. What is that? Carbon double bond to oxygen. Ketone. Aldehyde. Carbon double bond to oxygen. And this carbon double bond to oxygen is so important in organic chemistry that's given a name. And this is called the carbonyl group. Carbonyl group is carbon double bond to oxygen. You should know what is a carbonyl group and how to describe it in words. I'll say that again. Hint, big hint. You should know what a carbonyl group is and how to describe it with words. And it's easy. Carbon, double bond to oxygen, these two lines means their bond, this carbon is bonded to other things, because you know there are 4 bonds to carbon. And this is carbon double bond to oxygen, which is how you describe that. Carbonyl group. Now, it's important to remember that though the carbonyl group is called a group, it's not a functional group. Just like methyl group is not a functional group. But carbonyl groups are found in many functional groups. 2 of them are ketones and aldehydes. And I should be very honest with you. Somebody asked me, what kind of chemist are you? And I was really, really honest with them. And in my heart of hearts, I know I'm a carbonyl synthetic organic chemist. Because most of my work has been with the carbonyl group. And it's very sacred to me and very special. And hopefully you'll find out how much too. Not to scare you, but look at your skin. Your skin is made up of not ketones and aldehydes, but another functional group that has carbonyl group in it. So say, why is carbonyl group important? All you got to do is look at your skin, or look at, in my case, what hair I still have left. And that's made up of functional groups that have the carbonyl group. I know no more important thing to me personally in organic chemistry than the carbonyl group. And notice I'm happy when I see one even very special. So you should know what is a carbonyl group, how to draw it, carbon, double bond to oxygen. You should know how to describe it in words. Carbonyl group, carbon, double bond to oxygen. As I'll be doing the next number of chapters, I'll introduce you to new functional groups. So everybody say hello to aldehydes and ketones. Well, I'll introduce you to them. And then we'll go through nomenclature, IUPAC names. And then we'll look at where do you find them in the real world. And then how do you make them? And how do you react them, the fun part. All right, let's look at aldehydes. Well, I better put an aldehyde on the board. And if we look at this molecule, in order to name it, the first thing you have to do is identify the functional group in it. What's different will always help you. Ooh, an oxygen. And carbon double bond to oxygen. And it has a hydrogen on it and carbons. and we call that an aldehyde. Now, one thing, a term I'll use in class, and I use with other organic chemists, but I will never ask on test, what is it? The carbon of the carbonyl group, remember carbonyl group, carbon double bond to oxygen, is called the carbonyl carbon. You can do some wonderful things with a carbonyl carbon, which I have. But anyways, I'll use that term. So the question is, how do you name this compound? What functional group is it? Aldehyde. Carbon, double bonds to oxygen, hydrogen, carbons, aldehyde. Well, IUPAC rules for aldehyde are, and I've got it written for how it's in your book, if you bought the book, which you save some money because you have to, but find the longest carbon chain, which includes the aldehyde. Another way, now that you know the terminology, find the longest chain that includes the carbonyl carbon. Well, 1, 2, 3, 4, 5. Name that as an alkane. Pentane. Drop the E at the ANE ending of pentane, in this case the alkane name, and replace it with Al. Al ending tells you aldehyde. Now, important note, remember alcohols have an OL ending. Therefore, on test number 2, make sure you write clearly your names if I ask you to name something, because if I have to guess is that an OL or AL, I have a 50% chance of being wrong. So be clear when you write that out. All right, now, important thing. IUPAC has a rule that the carbonyl carbon, since it's so important, is always number 1 in an aldehyde, always. And therefore, you don't need a number, and therefore I'm done. This is called pentanil. And the rest of the way you handle substituents like alpha groups is the same. You number them from the carbonyl carbon being 1. Sometimes I'll draw the angle this way instead of this way. It's still showing 120 degree excuse me, bond angle. And if we look at this, the first question is to name this. What's the IUPAC name for the following is what's different? Oxygen. Oh, let's double bond to carbon with a hydrogen and carbons. And that's aldehyde. And now, how do we proceed? Find the longest chain with the carbonyl carbon, carbon double bond to oxygen. 1, 2, 3, 4. 1, 2, 3, 4. Either way it's 4. And 4 is butane. It's an aldehyde. I'm going to drop the E and add Al. Butanal. Am I done? No, because as soon as I say butanal, that's also, oh, look what's left over. It's your old friend, the methyl group. And so we have methyl. And what carbon is it on? Well, carbonyl carbon is always 1. It's on carbon 3. And that would be 3-methyl butanal. And that's how you do it. All right. I better share. So I'm going to keep all this one to myself. And what would be the IUPAC name of the following molecule? As I say on TV, try it, you'll like it. And I just did a generation testing on you people. See the sign sheet make it around? Came in late, it'll be up here. Let's do this. And in order to name this, first thing you have to do is identify the functional group. What's different? Oh, an oxygen is double bond to carbon with a hydrogen and carbons here. This is an aldehyde. How many carbons are in the longest chain that has the carbonyl carbon? Carbon double bond to oxygen. Don't know. 1, 2, 3, 4. Or I can do 1, 2, 3, 4, 5, 6. And I think you all agree 4 is larger than, smaller than 6. So this would be hexane if it was an alkane. It's an aldehyde, therefore I drop the E, add a L, hexanal. And now, if we look at this part is now spoken for. And what do I have left over? 2 carbons, ethyl group. And what carbon is the ethyl group on? Carbonyl carbon is always number 1 because it rocks. And therefore, it's on the ethyl group carbon 2. And we have 2-ethyl hexanal. By the way, say hello to my old friend 2-ethyl hexanal. Like I said, I'm having a lot of fun. And this molecule, this aldehyde, and special properties, I found that in parts and chemicals they do certain reactions in, allowed me to get my first patent and make a couple of compounds that they're still making. The company I used to work for is still selling it. And one of the compounds that this used to make is a fabric softener. So you wonder, why am I learning this stuff? Well, it's in our everyday life, or you can use it to make things in your everyday life. Now, there are 2 types of nomenclature skills you should have in organic chemistry, which is another way of saying there's 2 types of questions I can answer on the test, which makes it more relevant to you. That is, here's the structure, what's the IUPAC name? The other is, here's the IUPAC name, draw the structure. I'll do one, and then I'm going to let you try one on your own, because I should. And that is, draw the structure for the following molecule. How do you decode it to know what to draw? You start from the right. And the structure you're asked to draw is 3N-propyl nonanol. L. Al ending, aldehyde. If this were an E, nonane, 9 carbons. Nine carbons. Now, as I warned the other day, I don't break good habits, and I write my carbonyl groups on the right. You can just easily start at this end, and that would be perfectly correct on a test. I just don't do that. And therefore, Al ending tells me I have an aldehyde. It's always carbon 1 at the end. It can't be in the middle. If it is, it's another functional group called a ketone. And now, and propyl, I know what that is, 3 carbons. Where is it? On carbon number 3. 1, 2, 3. there you have 3N-propyl nonenal. And why don't you try this one? Draw the structure for the following molecule. And the name is 2-T-butyl octanol. Say that 5 times quickly. Those who are quicker than others, please be patient. All right, you have 2.76 seconds. 1, 2, 2, 5, 5. Done. All right, let's take a look at this. How do you decode this? You know what to write, draw. You start from the right, go this way. What's the ending? Al. That tells you aldehyde. If this were an E, octane, that's 8 carbons. At the end, since it's an aldehyde, I have a carbon double bond to oxygen, carbonyl with a hydrogen carbons. And now I continue this one. Oh, my favorite, a T-butyl group. And it's on carbon 2. Carbonyl carbon is 1, this is 2. I have a T-butyl group. And remember, it's your responsibility to make sure I always have 4 bonds to carbon. If not, tell me. And that's how you do 2-T-butyl, or you put down tert-butyl. I'm going to be slipping into a lazy organic chemist. T-butyl octanol. Now, that's how you do aldehydes. Let's look at ketones. Now, ketones are a little different. But in some ways similar, but still different. Because an aldehyde, because of its structure, always has to be at the end of a chain. A ketone, one thing I should point out, it's impossible to have an aldehyde in a ring. But there's one aldehyde I should talk about. When R is a benzene ring, UPAC in their infinite wisdom, and I do mean that sincerely, said this compound's been known for hundreds of years, and we're not going to change how they name it and say it. So they took the common name and made it the UPAC name. And it's called benzaldehyde. And a benzaldehyde aldehyde is considered just like a methyl group on toluene on a benzene ring, a substituent. And if you had another group on there, you could use orthomet and para. Anyways, this is benzaldehyde, and I'm not going to give it away, but this week, Tuesday and Thursday labs, which means everybody in here will get to smell this. And I won't give away what it smells like and where you find it in nature, because you can be surprised when you smell it and say, oh, I know that. I don't want to take that fun away from you. All right, let's go back to ketones, or start with ketones. And on the test, that's the IUPAC name. So if I wrote the structure, what's the IUPAC name? It's benzaldehyde. If I write the name, draw the structure, you should know that. Now, one bad habit, I don't think it's a bad habit, but it might confuse you a little, let me warn you about, is I can write this molecule this way, or I can show bond angles, and I can do something like this. These are both the same molecule. One I'm showing no bond angle, just straight across. The other I'm showing somewhat a bond angle here. And notice the longest chain is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I can write either way in class and also on the test. Another thing, there's no convention, but most of the time the carbonyl will go up, carbon double bond oxygen. But if it goes down, it's the same thing too. All it's done is rotate 180 degrees. Well, the question is, what's the IUPAC name for the following molecule? Well, how do you know what to do? Well, you look for what's different. Anybody having nightmares? Seeing me and saying, look for something different. I hope not. Anyways, carbonyl, carbon double bond to oxygen. On this side, I have an R group. On this side, I have carbons, a different R group. This is a ketone. And as I said, ketone is not spelled with a Y, even though it's pronounced that way. Now, how do you determine what's the IUPAC name for that? Find the longest chain that contains, the way the book has it, the ketone. The other way of saying is find the longest chain that has the carbonyl carbon. Okay, 1, 2, 3, 4, 5, 6. What is 6 is an alkane? Hexane. Now, for acyclic, you can have a ketone in a ring. Right now, I'm going to do acyclic, not in a ring, then I'll do the cyclic. What you do for a ketone, this is true for both, you drop the E at the end, and you add ONE. For some reason, I've never will say add 1. You add ONE. Now I have hexanone. ONE ending tells me ketone. That tells me, I've got a smile on my face. I love ketones. And now, there's an important thing. Where's the carbonyl carbon? It could be on this carbon, this one, or whatever. And similar to an alcohol in acyclic, you need a number to say which carbon is the carbon double bond oxygen or the carbonyl carbon. And you number from the end of the chain to get the lowest number to the carbon double bond oxygen. And notice if I go from this end, it's 2. From this end, it'd be 1, 2, 3, 4, 5. I hope you all agree 2 is smaller than 5. So we now have 2 hexanone. If you have alkyl groups, you number them just like you always have. I'll do this one, then I'll let you loose and have some fun on your own too. And that is what's the IUPAC name for the following. And if we look at this, we say what's different? Oxygen, just double bond to carbon, carbons here, ketone. And it's acyclic. What's the longest chain that contains the carbon double bond to oxygen, carbonyl carbon? Don't know. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So either way I count is 5, which is pentane. It's a ketone. Yeah. And therefore, drop the E, add ONE, pentanone. Next, which carbon has the ketone, carbonyl carbon? 1, 2, 3, 1, 2, 3. Either way, it's 3. Next, I have, your old friend, the methyl group, and what carbon is it on? We now are going to number from the side that gives this the lowest number plus this the lowest number, which means this, and it's on carbon 2. So you have 2-methyl, 3-pentanone. And the question is, what's the IUPAC name for that molecule? That's an important skill, counting carbons in my class. And organic chemistry. All right, looks like everybody's just about another 8.2 seconds. One and a half, 2. I got a broken pie. All right, let's go ahead. Let's look at this. Question is, what's the IUPAC name? Number IUPAC, which I haven't said in a long time, will never be on a test, but it's cool to say. International Union of Pure Applied Chemistry, the organization that was by treaty given the authority and the responsibility to come up with naming rules for all chemicals, and the most of their rules are organic molecules. But let's take a look at this. First thing you have to do, what's different? I can't look anywhere else. Oxygen. It's not carbon, it's not hydrogen. It's double bond to carbon. It's got carbons here, carbons there. Oh, someone already wrote it on the board. It's a ketone. And how do you determine the name of a ketone? Find the longest chain that has the carbonyl carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I hope you all agree 7 is the longest chain. 7, alkane name is heptane. You drop the E, add ONE. I can do that. Because that's the ending that tells you it's a ketone. Next, which carbon is it on? You start from the end to get the lowest number. So it's on 2. So it's 2-heptanone. And then I have, not 1, but 2 alpha groups. And one is an ethyl, the other is a methyl. And this would be carbon 3, this would be carbon 4. 3-ethyl-4-methyl. Now, since I'm not holding you to the IUPAC alphabet rule, if you put the 4-methyl first and then 3-ethyl, I would mark that correct. The IUPAC police would say, no, you shouldn't, but I will. Don't tell me, oh, I'm recording, I can't even use that anymore. All right, that's how you do acyclic ketones. Acyclic are ketones that are not in a ring. But the fun part of ketones, at least for me, are ketones in a ring. See the smile on the L1. Let's look at this molecule. What's different? Oxygen. And now, what is this? Oxygen, double bond, and what's there? Carbon. And what do I have here and here? Carbons. So really, this is a ketone, and it is. And how do you name it? Well, there's no longer this chain. Now, because it's cyclic, you find what's the ring it's in. Well, how do we name that as an alcycloalkane? How many benzene and liner carbons? 1, 2, 3, 4, 5, 6. That would be cyclohexane. Same thing as we did with acyclic. Drop the E, add ONE. And the carbonyl carbon, carbon double bond to oxygen of the ketone in the ring, is the best. It rocks. Therefore, it's always number 1. And everybody knows that, so you don't need a number. Just like we did with alcohols. But now I'm done. Cyclohexanone. And I'll do this one, then I'm going to give you some to have fun with. If we look at this molecule, question is, what's the IUPAC name for the following? And you say, what's different? What's not carbon? What's not hydrogen? Ooh, and oxygen. I'll take a break while all of you catch up with me. By the way, if you don't know already, catch up is organic. Molecules. All right, so we look here, oxygen, double bond to carbon, carbon's here, it's a ketone. It's in a ring, so what's the ring? 5 carbons, 1, 2, 3, 4, 5, and don't forget the cyclo. It's cyclopentane, drop the E, because it's a ketone, I'm going to add ONE. And now, am I done? No. I have an alkyl group, 4 carbons, the N carbon, N-butyl. And which carbon is it on? Carbonyl carbon is always 1. And you go clockwise or counterclockwise to give this the lowest number. And that would be clockwise, and it's on carbon 2. And we have 2 N-butyl cyclopentanone. And why don't you try this one? What would be the IUPAC? Oh, it's a pretty molecule. What would be the IUPAC name for that molecule? And it is. More specifically, carbonyls instead of cardiac. All right, everybody's giving me that look, start moving. So I better. What's the IUPAC name for the following? What's different? Carbon, double bond to oxygen. Carbon's here, ketone. It's a cyclic ketone because that carbon that's double bond to oxygen is in a ring. How many carbons in the ring? 1, 2, 3, 4, 5, 6. That means cyclohexane. It's a ketone, drop the E at ONE. And then I have 2 alkyl groups, methyl and N-propyl. This is 1, this is 2, 3, 4. Now I don't have enough room here because of the screen. This way you people by the wall and over here can see it. So I'm going to write it on top. And we have a methyl group on 3 N-propyl. So this would be 3-methyl. 4 N-propyl. Cyclohexanone, that would be all in one line. If you had written 4 N-propyl, 3-methyl, that would be correct. This is the correct IUPAC because M comes before P. You forget about the N when you're doing that. And even if you did, you'd still get that one, but that's how you do it. But I'm gonna have some fun. I have to. Do not write this down. This is a very complex bicyclic ketone that I made. These type of compounds for my pH. Don't write this down. And the name of this one is bicyclo 2,2,2-oxanone. Don't worry about it. I'll never put that. But I thought I'd say hello to an old friend. Hello. I really feel good. All right. Now, the other thing you should know in nomenclature is how to draw a structure from a name. And let's look at this one. And the question is, draw the structure for the following. 3-ethyl cyclohexanone. And how do you do that? You start from the right, move that way. And when I start from the right, at the end, I see ONE. That tells me ketone. If that were an E, that would be cyclohexane, which I know is a ring with 6 carbons. Oh, I'm having a good ring drawing day. And we have a ketone. Which carbon you put it on doesn't matter. Most of you are going to put it up here. I sometimes will put it there. That's carbon number 1. What do I have on that ring? On carbon 3 of the ring, I have an ethyl group. And I'm done. And why don't you try this one, 2-butyl or T-butyl cyclopentanone. What would be the structure of that molecule? All right, who moved the clock? Time flies when you're having fun with aldehydes and ketones. pull a big generation gap. I was going to say, when you're done, give me the high sign. If any of you have ever seen our gang, you know what I'm talking about. Go to YouTube, you'll know what I just said. All right. How do you decode this to know what to draw? Start at the right, get a pen that works. Success. Start from the right, ONE ending. Ketone, if that were a need, cyclopentanone would be cyclopentane. 5-carbon ring. I have a ketone, doesn't matter which one you put, carbon double bond to oxygen, most of you can do that. If this is carbon 1, carbon 2 is there and it has a T-butyl group. And that would be the molecule, 2-T-butyl cyclopentanone. Why don't you try this one? Draw the structure for 3-pentanone. And I'll give you, due to the time, 30 seconds. Go. Now 15 seconds. All right, we're into bonus time. I'll give you another 5 seconds. All right, put down your pens and pencils, and your notes. All right, how do we decode this? Know what it is? You start at the right, go this way, ONE ending, ketone. If that were a need, pentane. 5 carbons. Where is the carbon double bond to oxygen? Carbon 3. Doesn't matter which side you count. 1, 2, 3. And there you have 3-pentanone. It's important to put the number there. With that, I'm going to let you out a whole 17 seconds early. Those who have lab, be on time today. Remember, if you're late, I will not let you in.